All right, ready when you are.
So let me try this. So can you see my screen okay and hear me okay?
I think so, because I can hear you.
Andera?
We are all good. I'm going to remove I'm going to remove myself so my screen doesn't take up any space.
Okay, perfect. So good morning, everyone. This is obviously the first time for us to do something like this. We're super excited about it. A big thank you to Link3D for putting on this event, especially in the absence of some of the conferences that we're used to going to now. We also from EOS want to extend a message to the AM community that we hope everyone is staying safe. We're still excited for the future of additive manufacturing. We think that this could be an opportunity in disguise. What we want to talk about today is about a topic that we've been discussing and kind of preaching for a number of years, and it seems now more than ever that it's appropriate, and it's also timely to talk about supply chains, to talk about disruption, and to talk about some of the benefits of additive manufacturing in securing supply chains of the future. So just a quick introduction of who we are. So my picture is on the left-hand side of the screen, also I guess on the video. I'm the Senior Vice President of Applied Technology at EOS North America, together with Fabian Alefeld, who manages our Additive Minds consulting team in North America.
Good morning, everyone.
Yeah, Fabian, you want to say a short intro? Or I guess I did that.
No, I think you did good. Thanks.
Okay. For the rest of the audience, Fabian and I are going to be jointly presenting this. So roughly, I will do the first half of the presentation and Fabian the second half. But you'll hear us probably talk back and forth when one of us wants to chime in and add a point. So for those of you who don't know EOS, EOS is the global leader in powder bed technologies, both on polymer powder bed systems and also on metal powder bed systems. We sell and make materials that go in these systems and also the systems themselves. And there's a whole host of software that goes around with operation. Mostly, and to this point, we do not manufacture anything ourselves except for the printers and materials. So all of our customers sit in the supply chains, and we sit as suppliers to those customers in the supply chains. I think that's an important point to realize. More and more, our machines are equipped with connectivity. So some of the legacy systems and all of the future systems are able to be connected to a virtual network where all types of things can happen between setting up a build, monitoring how the build is going, understanding if any problems are occurring, using then technologies inside of the system to monitor what is happening on a materials level inside the build, and reporting that all back to a digital backbone. So the capabilities to connect these systems via the internet is alive and well. For today, we want to talk about four main topics. So first, the current supply chain problems that we see, also a little bit with some current events. We want to talk about global distributed manufacturing, what that means to us and what we think it should mean to the world. We have some examples to discuss and companies that are already up and running doing this, and then finally conclusions and a little bit of call to action and reach out to help. So first, let's start with some current supply chain problems. Sometimes I have the feeling, and I've been considering this, for the past few weeks as the coronavirus has really taken off worldwide, is what are some of the unintended consequences of these catastrophic events? And does it lead to tipping points of different technologies which may or may not have been around for a while? And I thought of the following three examples. And the first is telemedicine. And for those of you who don't know what telemedicine is, you probably have heard it in the past weeks, but telemedicine is not new. It's been around for the last 10 years. People have been trying to start different companies surrounding the topic. Teladoc is one. You can see the stock price down below just to show an indication of what's happening. So it caught some traction in 2018, and now, of course, in 2020, when everyone is in a work from home and in a lockdown scenario, doctors are still needed, communication with healthcare providers are still needed, and so now more than ever, I have the feeling that the whole world is kind of saying like, oh yeah, that's what you meant with telemedicine. And now they've realized the benefit of it, and they've realized the potential of it, and there's no reason why we can't go forward with this after a crisis to improve the overall healthcare system. So I think that's a great positive unintended consequence of an event like this. Furthermore, we've all heard scientists statements for years about global warming and the impact of the human effect on the global environment. And now we have the unintended consequence of probably the greatest experiment ever to prove that that's the case, in the shutdown of all manufacturing and production in China. And we can measure that in real time and see the decrease of polluted air being put out into the world. So I think now more than ever, we understand that humans have an impact on the environment, and now maybe this will spur us into trying to do something about it. Not all unintended consequences are completely positive. Sometimes there is a gray area and an unknown fact. So the two pictures you see there are from Venice, Italy. If you follow the news a few months ago, Venice was completely flooded under a few feet of water. There was a lot of talk about the pollution in the canals. Now with the city on lockdown, recently there's pictures circulating around with the Venice canals, and the water is completely clear and see-through. And some people are saying that the health of the water streams are coming back to normal. So while it is true that the water is clear now in Venice because boats are no longer churning up the bottom of the canals, the water is still very polluted, and so it's definitely not clean. And there's a lot of work to do to bring things back. So while something may look good from the outside, it doesn't necessarily mean that the entire problem is totally solved. So it's something to keep in mind as we push forward in the world of manufacturing. If we look at additive manufacturing and we look at some of the current events surrounding the coronavirus, we also see applications being developed. Some of them have unintended consequences which are positive, and some have unintended consequences which are negative, just as we discussed in the other events. On the left-hand side, you see a filtration mask, which is designed to be made additively. This mask has the potential drawback of not creating a good seal with the face, therefore giving healthcare workers maybe a false sense of security if they were to wear this mask, that they are safer than they actually were. This mask, of course, is better than nothing, but it's not as good as a traditionally manufactured mask that should be available today due to some supply chain issues. It's not. In the middle, you see a face shield. So this is a simple shield. This shield is great. It's well understood by anyone who wears it what it protects you from. It obviously doesn't form a seal with the face to block out fine particulate or 200 nanometer viruses. However, it is better than nothing. It can be made additively, so the orange parts that you see at the top of the face mask can be made additively, and then a cheap Mylar face shield can be attached to it. So this is a great application, and I think the consequences of this is that people really see some of the benefits and the fast turnaround time of additive technology. Finally, on the right-hand side, you see some of the issues currently happening with supply chains. So just last week or this week, President Trump in America announced an act in which major manufacturing companies like Ford, GM, Tesla will be asked and tasked to make necessary medical instruments, so ventilators, and surgical masks and the like for the healthcare workers of America. This is great. This is something that has happened in major crises throughout history, for example, in some of the major wars of the past. However, it's not always easy to take a manufacturing plant which was used to making Teslas and switch that to making ventilators. There is some ramp up time. There are some supply chain issues associated with that. And so in this call to action, it really highlights the clumsiness of historical supply chains and manufacturing capabilities. And I want to touch on that and see where additive can play a role. So first of all, why is it the case that that supply chains are inflexible, and how did we arrive to that place? And I think the easiest way to understand that is to talk about the bullwhip effect. This has been well studied, supply chains in the industry 1.0, 2.0, and even 3.0. Whereby a small variation on the right-hand side in the customer actions, all of a sudden everyone wants to buy a face mask, causes major variations on the supplier side and the manufacturing side. So if customers all of a sudden start buying a product, it takes a long time for a supplier to get ramped up because they do everything at scale. And so you have small trends affecting great changes in the supply network, and this has been a problem which companies have tried to address throughout the years. And if you look at most current supply chains, and if you see here, this is an image of what I would call a modern 2020 factory. In order to combat this bullwhip effect and to increase the security of their supply chains, there are supply chain engineers usually that work at these companies, and what they do is they identify weak links in the supply chain links that are unable to fastly scale or to act in a robust way, and they try to strengthen them either by getting in a new supply chain partner or getting in a secondary option for that one step in the supply chain. So what they've done is they've really strengthened and locked down all supply chains. And what happens when you make something strong and very rigid is you take away its ability to be flexible and agile. And that trend is something that I think needs to be considered. If we look forward and we look to what's possible with not a strong and rigid supply chain, but a flexible and agile supply chain, then we have to consider a switch from what we call Industry 3.0 to the buzzword of the last years in Industry 4.0. And what does that really mean? So Strategy and a kind of PwC company made a great picture, which I think highlights this in a very positive way. On the left-hand side, you see a traditional linear supply chain. And as we said, in order to improve this, people have concentrated on locking this down and making it stronger and more rigid. On the right-hand side, you see a supply chain ecosystem design. And we'll talk in a bit about a practical example of in real life of how this has been implemented. But essentially, instead of controlling a linear supply chain, you sit in a supply chain control tower and you distribute activities to different members of your supply chain. And you constantly monitor planning, order, and status, either from your distribution center, your production center, all the way to the consumer. And in this way, If one piece of your supply chain ecosystem goes down, it can be easily replaced and picked up by another. Additive manufacturing plays a great role, or is amenable to this type of supply chain ecosystem, because inherently the technology itself is flexible and not fixed. So on Monday, you can print parts of a ventilator in a 3D printing machine. On Tuesday, you can print parts of a Tesla automobile. There's no physical changes that need to happen. It's all a digital switch from one to the other. Of course, we are from EOS, so we show pictures of EOS machines, but this concept is obviously accurate for all of digital manufacturing, and additive manufacturing doesn't have to be just EOS machines. In real life, have we seen this in play? And the answer is yes. I think all of us have experienced this. We can take the example of the company Amazon. Amazon is a company who has definitely shifted their supply chain from a linear, fixed, rigid supply chain into a supply chain ecosystem. And we've seen the implications and the intended or unintended consequences of that as they've rolled it out. And so they've moved from standard shipping to same-day shipping, and finally to Amazon Prime Now, or depending on which city you live in, potentially when you order something, it can, of course, arrive in just a matter of hours. And how did they do this? And what they did is they took away a lot of their controls and a lot of their oversight, and they instituted flexible workforces and a distributed model in order to get their goods from a localized storefront to the final consumer. So with standard shipping, Amazon would have total control over that process, and they would employ large professional companies like the U.S. Postal Service to deliver the package to us, and this would take 3 to 5 business days. Remove the U.S. Postal Service and implement crowdsource delivery and localized storefront storage. And what you have now is the ability of Amazon to get those packages to us in a much faster way. However, Amazon has given up control. They don't know exactly who that Uber driver is who's going to deliver that package to us. They don't know the exact conditions of all of the storefronts in every city. So they needed to loosen their grip on the ecosystem in order for that ecosystem to act in a more customer centric way. And what we really find is that customer centricity drives this new way of supply chain ecosystems coming to the forefront. So I think my kind of final point here is that we are in a period of change from supply chains which are locked and rigid to supply chain ecosystems which are flexible and able to adapt in periods of crisis. And we see that playing out right now before our eyes as medical supplies are not able to be manufactured or gotten to the medical professionals in a timely manner. Large companies like GM, Ford, and Tesla struggle to shift their manufacturing capabilities to make new products and to be reactive as much as we had hoped that they will. So Fabian, I'll turn it over to you now to talk about global distributed manufacturing.
Awesome, thanks. Yeah, and maybe to continue the story that Greg just told, I think we all understand that especially Amazon has really revolutionized and even democratized the supply chains. But what they're not able to do as of today is to revolutionize the early stage of those supply chains, which in the end are highly dependent on manufacturing. And Greg, if you could go on to the next slide. then we can talk a little bit about how additive manufacturing can play a role here. And I think if we look at the 4 pillars of the implementation potential of additive manufacturing, where most of the time we usually talk about product disruption, so developing completely new applications and use cases that are not substituted, but really leverage the full potential of design, especially in additive manufacturing, and even optimizing internal operational performances through, for example, the implementation of conformal cooling challenges. We rarely really talk about simply creating a safety net with additive manufacturing in traditional supply chains in times of disruptions. And I think today we can all realize that even though we're so used to Amazon Prime and same-day delivery, that is not the case anymore. Amazon does not deliver on the same day. Why? Because they have manufacturing issues that they are not able to resolve just by recreating the end of the supply chain. So I want to touch base a little bit on the supply chain performance increase through additive manufacturing, and also take it one step further. How can we set up ourselves for the future, and even implement completely digitized and automated production environments by utilizing additive manufacturing, even in combination with traditional manufacturing methods. Greg, if you could go to the next slide, please. So if we compare additive manufacturing with traditional manufacturing methods, we can see here in this perfect visualization that's done by McKinsey that the additive manufacturing process steps are just significantly less than the traditional manufacturing steps that we've also seen in Greg's part of this conversation, which means we have many steps that are dependent on each other. If the initial step, for example, here the hot rolling has some issue, we have the bullwhip effect that basically then trickles down and delays the whole manufacturing and value and supply chain. When we look at additive manufacturing, the only initial step that we depend on is the atomizing of our material, whether if it's on the metal side or on the polymer side in powder bed fusion technologies, which means that we're way more flexible in our supply chain and our sourcing, and we have almost no ripple effects downstream, where we then can achieve full supply chain flexibility. As Greg mentioned, if I am today a manufacturer with a additive manufacturing equipment, I can now produce a mask right next to a ventilator part in if they're both utilizing polymer technologies. And therefore, I have complete asset flexibility, and I can produce that on demand, which means that I have no part inventory, which is also a huge factor for a lot of organizations. We in the US alone have a inventory cost and capital that's stuck in inventory that's the size of the GDP of Australia, which means that a lot of resources could be freed up by implementing a parallel supply chain of additive manufacturing to mirror certain changes in demands. If you could go to the next slide. And I see we have 5 minutes left, so I'm gonna speed up a little bit. And Greg, if you could click one more time for us to see the whole animation. So that means that we now experience, as Greg also mentioned, that we're highly dependent on centralized factories, right? If we look at masks now, they are mainly manufactured in the APAC region, where now months ago, the disruption of the manufacturing supply chain significantly slowed down, number one, the manufacturing of those masks, but number two, also we had an increase in demand, and our unflexible supply chains were not able to complete that shift. So when we add additive manufacturing to the mix with complete asset flexibility, whereas now we understand that certain demands are going down and the demands of this example in masks is going up, we can completely switch this demand over. And even though we have even transportation struggles from the APAC region to North America, if we have localized manufacturing cells here in the US or in Europe or wherever you are, where you can now produce on-demand products for the local demand, we are way more flexible and we're less vulnerable to disruptions in our supply chains due to pandemics as we experience today, due to trade wars as we experienced before and are actually still experiencing. The media is just not covering it as much, or even natural disasters that, as Greg talked about, climate change are still increasing and will have a big impact on our global supply chains. So if you go to the next slide, and yes, that will be disrupted. We can also see that that's nothing that just US is making up to promote the technology. But if we look at another global consulting organization, EY, they did a study with their top 900 customers and asked them about their current use and future use of additive manufacturing. We can see that under the top 5 implementation reasons for additive manufacturing are supply chain optimization and related usages. As we can see, the top winning one is to manufacture a product that better meet customer requirements. Number 1, from a physical perspective, so from a performance perspective, and number 2, also from a demand perspective, as we are shifting radical demand shifts in the consumer behavior. And the second top winning ones are number 1, to reduce logistics efforts, transportation and inventories, which I was just talking about, and also to become more efficient in the after-sales market by producing spare parts on demand. That also means that we can reduce inventory and capital that's locked down in our warehouses. If you could move forward, Greg.
So Fabian, I think we have, I'll make the executive decision. We'll go 5 or 10 minutes over, so we don't have to super fly through this.
That's perfect, and I think Janet is on board with that, as I know her. EvoBus. EvoBus is a great example of an organization that made that shift early and now has a flexible supply chain in parallel to a traditional supply chain and manufacturing, which means that they can also ramp up their demands based on their customer behavior. So EvoBus, if you have not heard of them, they are now a part of the Daimler Truck and Buses organization, since Daimler reorganized internally. But as a lot of automotive organizations, especially traditional automotive organizations, they have a huge spare part portfolio, and they also have governmental restrictions or requirements to keep a certain warehousing effect and spare parts numbers on demand, on stock, to be able to deliver to their customers. In the end, it's all about total cost of ownership, which means that also their customers need shorter lead times and expect EvoBus, or now Daimler buses, to deliver those spare parts right radically. That means in the end for EvoBus, before they went into, they were highly dependent on warehousing. They were highly dependent on keeping a lot of capital in their inventories to complete their customers' demands, which weren't decreasing, but which were increasing by roughly 10% a year. So their 320,000 spare parts were even increasing year by year by year. So what did we do with EvoBus, and what did EvoBus do to get rid of and get out of this dilemma that would only get worse over time? They completely shifted their mindset and built up a parallel supply chain and manufacturing for certain spare parts that were slow movers, that had high minimum order quantities but low demands from their customers, or were last time buys, where tooling costs were would significantly impact the total cost per part, since the demand was so low. So EvoBus shifted their focus to those spare parts that are one-to-one replicas of injection molded or forged parts, if we talk about the metal spare parts. And we were able to create a process with EvoBus that completely recreates parts and has the exact look and feel as the injection molded parts, and the end consumer doesn't even realize that there's a difference in the manufacturing technology. That gives EvoBus the opportunity to deliver, as quoted here by Daimler, the same high quality requirements in terms of reliability. So their lead times are also met to deliver customers the parts at times where they need it, and the same functionality. So we have the same material properties and the same touch and feel, even the same color that traditional manufactured part had, but more economic. That means Daimler is actually able to reduce their investments and costs by reducing their working capital significantly. And that's a case study that's has been in the additive world for a while. Nobody talks that much about it because it's simply just recreating and substituting parts, but it has a huge effect and it's super scalable. So now Daimler is in the position where they only print 200 parts on demand, but now that they have this process chain in place, they're super flexible and they can now scale that up significantly, especially in times of disruption, and they're not as reliant on their traditional suppliers anymore that might have some issues or even don't want to produce certain parts since that's not even economic for their suppliers. Okay, next slide, please. Another case study that Greg just talked about, and I'm just going to go over it quickly because I think even all of the participants who have been on LinkedIn have seen those examples of producing masks. As Greg said before, if we substitute those masks in those manufacturing processes, we can deliver very quickly and we can fulfill a demand in a supply chain that cannot be met currently by those traditional manufacturing methods. Since the switch takes really long and the lead times are quite long for producing new tools, for example, and we can completely recreate those masks, and we can produce those with our technology. Now, if you're talking to engineers within EOS and within our customers, engineers always love to improve things, and we're always problem solvers. So now we're even taking it a step further where we say, okay, we can reproduce those supply chains and we can run a parallel manufacturing chain. But since complexity is free with additive manufacturing, why don't we try to even optimize those masks to give our health workers that are desperately in need of secure personal protective equipment? Why don't we even optimize those products to their face geometries to even give them a better protective equipment to keep them on the job and keep our healthcare system in place? So that's what we're working on right now, is to partner with certain software organizations to give our healthcare workers access to even better protective equipment that they had access before by utilizing those new supply chains with additive manufacturing. And last but not least, internally within EOS, we are also building up a global additive manufacturing production network. We're not only working in localized cells, where the North American market is producing in Austin and Novi, for example, near Michigan, for the North American market, but we're now creating, with the help of Link3D, a global connected additive manufacturing cell network. And that allows us to, number one, be very flexible in local demands. If we, for example, now have a shift in demand more into the Asia Pacific region, we can balance that shift out with the North American production capabilities that are virtually connected in one global factory. And if Greg wants to go to the next slide, you can see a few screenshots of our production management system that we use with by Link3D. And
Fabian, this map is also accurate, right? These are all the things that we're connecting together.
This is the exact map of our manufacturing cells, correct? Those are all EOS locations. It's not a made-up map that I copied from Google.
Right.
Yeah, and as you can see here, we have a global production planning tool in place with Link3D, which means our colleagues from Asia Pacific can also have access to our systems here in Austin and vice versa. and also gives us the opportunity to really run a significant and detailed data science projects and data analytics over, for example, our system utilization. How can we increase our system utilization to become even more productive with the same amount of assets, and even run more production and market required analysis, such as which part sizes are in demand right now. Are we moving, are we experiencing a shift towards larger parts? Are we experiencing a shift towards smaller parts, which even gives us some indications about the future R&D projects. Even though we made the decision to run a bit over time, I want to end it in a few minutes, in 4 minutes. So just a quick side note, of course, this is not the end, and we're just in the beginning of a industrial revolution, and everybody who's on this thread and is listening today probably also has a little bit of experience in the manual processes of additive manufacturing, which still slow down the agility of those manufacturing processes. So we're now working, number one, with partners to completely automate those manufacturing cells. In this case, we work with Daimler and with Premium Aerotech to create a fully automated and digitally connected manufacturing cell. And we also have the exact same cell in our headquarters in Kreiling, where we're also running our internal production of certain machine parts, fully automated as of today. So that means if Greg, we want to go to the conclusion slide, and maybe you and I can have a little bit of a discussion here. That means that if we look at all that we presented today, we have certainly, and we can all agree, challenges in our supply chains. Those supply chains have been completely optimized for especially our the 20th century. But once we entered the 21st century, I think we all realize that we live in a world where new developments and new technologies come up on a monthly basis. We have shifting customer demands, and we also need to now optimize our manufacturing towards those new demands. So what we can see here is a slide that Greg drew, and I think I'm actually going to let you explain it. Yeah, go ahead.
Thanks, Fabian. So just here's where we want to end the presentation. So when many companies step into additive manufacturing, quite often they step in to the left side of this diagram, and this shows the volume life cycle of a typical product over its life. So in prototyping, in new designs, everyone sort of gets the fact that additive manufacturing can be utilized there. What they don't oftentimes think about is all the way on the right-hand side, which is the example we showed with Daimler, whereby additive manufacturing can be utilized in a financially and time beneficial way to address end-of-life spare parts. If you combine the design and development on the left-hand side with the end-of-life spares and supply chain flexibility on the right-hand side, you can quickly see that additive manufacturing is a viable and flexible production tool that should be added to your traditional manufacturing toolbox. Of course, there will be those high volume, simple parts where injection molding in terms of cost per part will still take priority. However, for flexibility and for dealing with dire circumstances, having the capability in your designs and the capability for your spare parts to utilize additive is extremely beneficial, and we see these use cases happening throughout the world. So with that, then I think let's end the presentation, Fabian?
Yeah, I think that's
okay, so
10 minutes over time. I think is still okay. Andrea, right?
Okay.
Yes.
So
well,
thank
you for the
everyone.
presentation. We do have a few Q&A as well in the side. I think we can take a few minutes to answer some questions. So The first one is from Duncan Gibbons. It says, "Hi, Gregory. What implications does moving from rigid to flexible have when it comes to qualifying the manufacturing process? Does flexible mean non-standard processes and therefore harder to qualify?"
No, that's not the case. So we work a lot with thinking about what qualification means. We work in many different industries, and we think about things like OQ, PQ, as in addition to installation qualification. We work with aerospace and automotive companies to set their standards that they want to utilize. Having a qualified machine to build a qualified part is possible today, and that same machine can be utilized to manufacture multiple different parts. So you can have qualified production on an additive manufacturing machine while maintaining flexibility. That's definitely possible. We're happy to talk more. You can reach out to us. We have groups of engineers that work in this area.
Thank you, Gregory. Another question from Priyesh Mehta. Sorry if I pronounced that incorrectly. Hi, Fabian and Gregory. Guten Morgen. How important is the repeatability between two machines for distributed manufacturing?
Very. 100% repeatability between two machines. It goes to the same topic of qualification. Of course, additive manufacturing being a layer by layer process, it's going to have different metrics when it comes to repeatability than an injection molding process would. Injection molding processes have distributed material properties that come out of that process. Additive manufacturing has distributed material properties that come out of its process. Having a qualified build with stabilized properties is necessary. And what we see from an EOS standpoint in the world today is that this is possible, and companies are using additive in this way.
Okay.
Awesome.
I see a question. What's the business case in making the same one-on-one parts? Only lead time, 2 different parts at 200 parts in total. So I can answer that. I think here the hated answer is it depends. It really depends on where your part is in your production cycle. If we talk about the aftermarket and if we talk about spare parts, it's not lead time significantly. It's more number one, slow moving parts. So inventory cost reduction has a huge impact on the business case. So we always need to look at the whole picture of the life cycle of a part. Last time buys are very often the deciding factor for a positive business case, whereas a last time buy could require me to buy, for example, 1,000 parts of that supplier, but I only have a demand of 1 part a year. So therefore, I have a very easy business case to calculate where I could have a 100-fold cost increase by additive manufacturing, which would still justify using that technology. If we look about parts or add parts that are still in production and I want to build up a parallel network, I can look at complexity. Complexity oftentimes has a business case at a certain point where if we compare it to milling, for example, highly complex parts are very expensive to mill, and additive manufacturing can compete in higher complex geometries. If we look on the polymer side and compare it to injection molding, for example, lower volumes where with high tooling costs have a business case where, of course, here all also comes down to the number of parts again, and depends on the part and on the tool where we can identify the business case for that certain part. In the end, it really needs a in-depth analysis of a organization's full value chain, which we do on a weekly basis, where our engineers and the engineers of some organizations come together. We analyze the supply chain, we analyze the production processes, and we identify those levers that we can pull in order to have a positive business case.
Perfect, Fabian. So I see 3 other questions, and I'll try to answer them all in one statement. So first of all, there's a mention of the concept of digital twin. So you cannot do distributed manufacturing, you cannot have a flexible supply chain if you don't take advantage of the concept of creating a digital twin of your part. So that's not only the design file of that part that needs to be made, but it's also the properties that that part should have, including the pre-processing and post-processing of that component. Post-processing, of course, needs to happen in all manufacturing steps. So in additive, that needs to happen as well. And so utilizing a digital twin doesn't just mean having a copy of your CAD design. It means understanding the entire value chain and the entire process chain that needs to happen for that part, including post-processing, which needs to be factored into your business model, like Fabian just talked about. And finally, as you go through this transition from a fixed supply chain to a flexible supply network, taking advantage of having a digital twin and taking advantage of designing and understanding the post-processing necessary to make parts additively will allow you to make smart on-the-fly decisions, where if you have long lead times or low time demand for your components, maybe traditionally manufacturing would be your better choice. But if you design your part ahead of time, thinking ahead that maybe you would need to use additive at some point, but also you would like to still be able to use subtractive at other points, then you can easily create parallel manufacturing chains and switch back and forth between the two, and make a constant balance between time to procurement, cost per parts, and understand the business case in both instances. That's all we have.
Awesome. Thank you guys so much for the presentation. We are now going to be going back to the virtual networking session. Our next presentation will begin at 10:30. So as we start the presentation, if anyone has trouble connecting to the presentation, we will also provide a link in the chat to a YouTube where it'll be live streamed. And if you're currently watching from YouTube, feel free to rejoin Remo, and we will start the networking session. Thank you, guys.
Thanks again, everyone. Stay safe.
Thank you. And if there's any additional questions that come to mind during the conference, or that you didn't get answered specifically yet, feel free to reach out to us, and we'd be happy to get in touch with you afterwards and have a conversation on the phone or via video chat.
Thank you.